Writing linear equations. This is always a fun part of Algebra 1, Algebra 2, geometry, because we do it all the time. We probably did it in pre-algebra a little, but we certainly take it to another level as we move along through our algebras and our geometry. So we're going to be doing that, writing linear equations, right? Given the slope and the point on the line, and we're going to do it knowing about parallel and perpendicular situations. And so you just gotta kind of know how things work and fit together, and stop trying to memorize and just try to learn how these things are connected. Slope-intercept form is our favorite, y equal mx plus b, where m is the slope and b is the y-intercept. That says that. Point-slope form is this one. We didn't do as much with this. I think we just maybe looked at it a little bit in Algebra 1. We will definitely be looking at it today. It's y minus y1 equal m, or slope, times the quantity x minus x1, because it's where you know a point and the slope, and you can write the equation of the line. That's why it's called the point-slope form. This one is called a slope-intercept because you know the slope and an intercept, and you can write the equation of the line. So the names kind of betray what you're dealing with. So we have those two in standard form. Those are the three forms we mentioned in the previous lesson. Parallel, or lines that have the same slope. Now in elementary school we said parallel lines are lines that never intersect. Well, the problem with that definition is, how do you know they never intersect out there somewhere 102 miles from here? How do you know? You can't tell. You can't see out that far. But if they have the same slope, then they don't intersect. They're parallel. Perpendicular lines are lines, it says two oblique lines. That's a nice, cute little word. But it's lines whose slopes have a product of -1, because perpendicular lines have slopes have lines whose slopes are opposite reciprocals of each other. In other words, if there's a slope that's 2, its perpendicular has a slope of a -1/2. Because what happens when you multiply those two things together? You get -1. If you have a line whose slope is 2/3, what's the slope of its perpendicular? A -3/2. Because when you multiply those things, what do you get? A -1. I'll say it again. Those slopes are negative, let me change that word, opposite reciprocals of each other. Opposite, because the signs are opposite. They have to be opposite, so when you multiply you get a negative. Signs are opposite, and the reciprocals, you flip them, right? Remember reciprocals? And that's how that works. So it says find the value of r. I got to go back and deal with this just because. Just because. I got to go back and deal with this. So this says 6r, a point, and 3, another point, have a slope of 2. Find the value of r so that the line that passes through each pair of points has the given slope. Now, you look at that problem, you're like, I don't know what, you know, let me just help you right here, nurture you just a little bit. So we have y2 minus y1. Remember this formula? Of course, it's the slope formula. And we've got all the pieces and parts here to plug into the slope formula beautifully. So let me call this my x2, y2, which is my habit, and this is my x1, y1. And so I'm going to do my normal fraction bar with my minus signs, and I'm going to plug all my people in the place where they belong. So my y2 is r, my y1 is 3, my x2 is 6, and my x1 is 3, and my m is 2. Now, look what I've got. I've got an equation with one variable, r, that I need to know the value of. So let me clean that up just a little bit. So 2 is equal to r minus 3 over 3. R minus 3 over 3. If I want to solve this equation, I'll probably get rid of this division 3. We multiply both sides by 3. And then I would add 3 and find out that r is equal to 9. Now let me come back to here. And I believe r is equal to 9. And what you could easily do is take those 2 points and check and see if they have a slope of 2. And check your work. But look how that works so nicely. Now, if you didn't know to use it, you didn't know to use it. But now you've seen it, and so now you know. Same problem, same stuff, same deal. Different problem, different process, or same process. Okay, let's get into today's lesson. So we know for slope-intercept form that the m is the slope, the b is the y-intercept. We usually just say slope-intercept, but we mean y-intercept. And remember, every y-intercept that ever lived, the x is 0. Just say that now, we'll may use it some later. So let's write the equation of the line given the following information. The line passes through this point with this slope. Okay, so I'm just going to make a note, that's my m. That's my slope. I'm also going to make the point that this is my b. Now, they didn't tell me that it was b. They didn't say, this is the y-intercept. It's not up there. It's not here. It doesn't say that. How do I know this is a y-intercept? Because every y-intercept that ever lived, the x is 0. So just like that, ta-da, I know I'm going to be using the slope-intercept form where I already know the slope is 2 and the intercept is 6, and I am done. That's it. That's all I got to do. That was an easy one because they gave me the intercept. Here they did not give me the intercept. That's not the intercept. So this is write the equation of the line given the following information. The line passes through this point with this slope. So this is the slope, and this is just some random point. Some random point. So what do I have here? I have a point and a slope. So I'm going to use my fairly new formula, the point slope formula. The point slope formula. You could use that. It's a useful thing to do or to have. And so then I just drop the people in where they belong. So I'm going to put my y minus and my x minus, parentheses, and I'm going to put my stuff where it goes. So what is my y1? My only y is 3. What is my m? It is 2. What is my x? My only x is 1. And now, after just a tiny bit of work, y minus 3 equal 2x minus 2, right? Well, by the way, that is an equation of the line that has that situation. But I'm going to go ahead and put it in slope-intercept form since I'm familiar. And so then I add 3 to both sides. Add 3. And there you go. What's slope? 2. Does this point work? If I put in 1 for x, do I get 3? Put in 1 for x, do I get 3? Yes. Same problem, right? He's like, why do you have the same problem up there? Well, in Algebra 1, we did this thing called hunting bees. And because we know this is the slope, and this is our slope-intercept form, I'm going to take that, put the slope in that place, and have this. Would you agree, if I knew the B, I'd be done. That's why I'm hunting bees. If I knew the B, I'd be done. That's why I'm hunting bees. So I want to take this information right here, that's X and Y, and I want to plug them in. So there's my Y is 3, and my X is 1, and my B is what I'm looking for. That's 2, subtract 2 from both sides, B is 1. Which means this equation becomes y equal 2x plus 1. 2x plus 1. Remember that? 2x plus 1. Now, which one do you want to do? It's up to you. It's your choice. You can back this video up, watch it again, watch it 3 times, and try to grasp what I'm doing in all these cases, because if you didn't see me do the hunting bees before, I did it really quick, and I know that. But it's something we would have spent a lot of time doing in our Alg2 class. All right, so we're still writing equations for lines with different conditions or situations. Here, they don't tell us the slope. They didn't tell us the slope. They did not tell us the slope. They didn't tell us the slope. So we don't have the slope. We don't have the slope. We have 2 points. And sorry, but we don't have a point-point equation or form. We have a point slope. We have a slope intercept, but we don't have a point-point. So I need to know the slope. They don't tell it me. I need to know it. So how am I going to find it? I can do a graph and do rise over run, or I can do the little formula. If I want to do the formula, I copy my formula. You should be doing that yourself because you should know how. And this is my x2, y2. This is my x1, y1. That's my habit. You know that already. And so I'm going to plug my pieces of parts in because I want to know the slope. So my y2 is 3. My y1 is 6. My x2 is 1. And my x1 is -2. Which means I have a -3 over 3, which is -1. Right? Because 3 minus 6 is -3, and this is really 1 plus 2, which is +3. So now I know my slope. So I'm just going to put that up there. Slope is -1. So now I know a point and a slope. So what can I use? I can use the point slope formula. Or I can go hunting bees. Either one. If I want to use the point slope formula, my y1 is 6, my m is -1, and my x is -2. So that's y minus 6 equal -1 times x, and a -1 times a +2. Do you agree that's a +2? It's a double -2, it's a +2. -1 times +2 is -2. So I add 6 to both sides, add 6 to a -2, plus 4. Now, I believe this is it. It does have the right slope, or at least the slope that I found. But look what happens when I put a 1 in here, right? When I check these points, put a 1 in here, because -1 plus 4, what is -1 plus 4? 3. Put the -2 in here. If you put a -2 in here, you got a double -2, which is a +2, and 2 plus 4 is 6. Boom. So this is not randomness, right? This is not randomness. This is stuff that we're doing, stuff we can look at really, really quickly. Write the equation of the line given the following information. So in this particular picture, they just give me, well, they gave me a picture. Gave me a picture, and it's got some points on it, and so that's what I've got. I could find the slope with the formula. Either these 2 points, these 2 points, or these 2 points. I can find the slope with the formula. Or, since I've got the picture, I could just go rise 1, 2, 3, 4. Right? 1, 2, 3, 4. Run 1, 2, 3 in the negative direction. Rise 4, run -3. Slope is -4/3. Is that okay? I could do that. I could do that. So slope is -4/3. And I could use the slope in this point and go hunting bees, or use the slope formula, or point slope formula. Same thing here. But look at that one. What is that one? What is that one? What is that one? That's the y-intercept. That's the b. Oh. So if b is 3, I got these 2 pieces of information. I can really, really quickly use the slope intercept form, where the slope is a -4/3 and the b is 3, and I'm done. That's the equation of the line. Now I could check, like I could put the 3 in there, and the 3's cancel. Got -4 plus 3. What is -4 plus 3? -1, yay. I can do the same thing, I check those. What kind of slope is this? Positive or negative? Negative. So it means the first 2 are not even plausible. Can't happen. They got positive slopes. Notice the y-intercepts are the same in both of those. They're at 3, so that doesn't help me. So it comes down to the slope. Rise 1, 2, run 1, 2, 3, 4, 5, 6 in the negative direction. Rise 2, run negative 6, slope is negative 1/3, answer is D. It's the same problem. Answer is D. Write an equation in slope-intercept form. Write an equation in slope-intercept form. I've got a picture. I can easily find the slope. Rise 1, run 1, 2, 3 in the negative direction. So the slope is a negative 1/3. That's easy. I don't have the y-intercept. The y-intercept is here in the middle of nowhere. So I don't have that. It's going to be a fractional thingy when I get it done. I could use the slope in one of these points, either one of them. Like that one. His name is 2, 3. So I could use those two pieces of information and do the point slope formula. I'll just write those down and use the point slope formula. Because that's what I know is a point and a slope. I'm not taking a lot of time to stress that, but I'm using what works because of what I have. You know, work with what you got. Well, you got to have the right system. I could go hunting bees with those same two pieces of information. I could. But I'm just going to use this because we got to know how to do this in our Algebra 2 class. So the y is 3. The slope is a negative 1/3. And the x is 2. So a little work here. Distributing the negative 1/3 to the x. And the negative 1/3 to the 2 becomes a plus 2/3. And if I want to move the y over, it's a negative 1/3 x. And I'm going to add 3 to both sides. Now that's a little bit of a deal. I've got 2/3 plus 3. Because I'm going to add 3 to both sides, right? So I'm going to have 2/3 plus 3. You could just quickly call that 3 2/3, which is 11/3. That is 3 2/3, right? It's 11/3. Another way to have done that might have been to call this 3 9/3. It is 9/3, isn't it? Think about it. And that's 11/3. 11/3. Could you have left it as a mixed number? Yes, but in algebra we don't mind those fractions. We don't even mind those improper fractions. We don't mind them at all. And that's the answer they got. Point slope form, I've been using that throughout the whole deal here. There is a stat button on our calculator that most of us don't have anymore. But I do want to remind you that parallel lines have the same slope, perpendicular lines have slopes that are opposite reciprocals because of what we're about to do. It says write equations for each of the following situations. We have 5 of them. First one is super simple because they give us the slope and the intercept. So we take the slope-intercept form. We drop the pieces in the places where they belong. This is very, very elementary, and we are done. That's it. That's it. In the second one, they give us the slope and the y-intercept. See, here they call it the b, here they call it 0, 4, but every y-intercept that ever lived has an x that is 0. So technically that's the b. So I use the same formula, the slope-intercept formula, where the slope is a negative 3 and the b is 4. I'm done. That's how that works. That's number 2. Number 3 says passes through this point and this point. Well, let me just say, first of all, that's a b. I'll use that later. And then I've got to find the slope here. I've got to find the slope. And I either find the slope doing rise over run on a graph or using the slope formula. I've got to find the slope somehow, okay? So the slope is 2, I believe. Let me you're gonna rise 6, run -2. Oh, run -3. I'm trying to cheat, sorry. Like I said, use the formula or graph it and actually count rise over run. So I'm believing here that the slope is -2. If that's true, then I have the slope and the intercept, y equal mx plus b. I'll find out in a minute if this is true or not. If not, I'll have to fix it. So it's a -2x, and the b is 2. Well, certainly that works. Does this one work? That'd be -6. If you put the 3 in the place of x, it'd be -6, and -6 plus 2 is -4. Yes, it did work. This one, they don't give me the intercepts at all, so I'm going to have to do that the way that we did those earlier ones, where I'm going to have to find the slope and then either use the point slope or hunt the b's. So those are just practices that we can do. I'm going to do a couple more here just to remind you one more time. All right, write an equation in slope-intercept form for the line that passes through that point, or has that slope and passes through that point. So if we call this x1, y1, our formula is y minus y1 equal m times the quantity x minus x1. It's our point slope formula because that's what we've been given, a point and a slope. So my y is -2. My m is -3/5. And my x is 5. So that's y plus 2. They do ask us to write it, I need to make note of that, in slope-intercept form, so it's y equal mx plus b. Otherwise, that is an equation with those conditions, but they asked me for a specific form. So y plus 2, and this is distributive property, -3/5 x, and what? So negative times negative is a positive, and the 5's are going to cancel, and I get 3. So y is equal to, because I'm putting in y equal mx plus b form, slope-intercept form. So I subtract the 2, so I have the -3/5 x, subtract the 2, be a 1. I could check that by plugging that point back in, see if it works. I can also see the slope. I do want to go back and say, well, we could have hunted the b's. I only did it once, so I want to do it one more time before we get done. So y is equal to, the slope is -3/5 x plus b. If we just knew the b, well, we can find the b. How do you find the b? You can find the b by doing the hunt and b process. So my y is -2. My x is 5. And the b I don't know. That's what I'm hunting. So that's -2 equal, the 5's cancel, -3 plus b. What happens when I add 3 to both sides? So to isolate the b, I add 3 to both sides, I get 1. Add 3 to both sides, I get 1. Which means this equation turns into y equal -3/5 x plus 1. Because the b was what I was hunting, I found it, I put it back in, I got that. It's the same thing I got here. So it's 2 ways to do the same problem. We got it right. Of course we did. And this just plows through more of those same ones. Let's get to the parallel and perpendicular. Parallel lines have the same slope, perpendicular lines have opposite reciprocals. So you can look at this and you can see these are parallel, they have slopes that are the same. You can look at these and see they're parallel because the slopes are opposite reciprocals. One's a 3, the other one is the opposite sign with the reciprocal of 3. If you multiplied their products, you would have gotten -1. Write an equation in slope-intercept form for the line that passes through this point and is perpendicular to this line. Okay. So let's kind of walk through this. So what's the slope of this line? slope, -5. So if we want this to be perpendicular, what's the slope of the perpendicular? 1/5. Opposite reciprocal, right? So we're looking for a line with this slope through this point. That's what we're doing. This is the information we're working with. Because this was the slope of the line they gave us, but we're doing perpendicular, so it's the opposite reciprocal. If you multiply those, you get -1. It's the opposite reciprocal. So we're looking for this slope with this point. We've done point slope already. You can use the point slope formula, or you could hunt the B. You can do either one. I'm going to use the point slope formula. It's the one we've used the most today, so I'm going to do that just for familiarity. So the y is -2, the m is 1/5, and the x is 3, right? The x is 3. So that's y plus 2. That's 1/5 times x, and 1/5 times a -3. So I'm going to subtract 2 from both sides. 1/5 x, and I'm going to subtract 2. Let's make a note of that. I've got a -3/5, and I'm going to subtract 2. Probably the easiest thing to do here is to say, well, 2 is 10, oops, that's a minus sign. 2 is 10/5, isn't it? It is. And a -3/5 subtract 10/5 is a -13/5, and that's our answer. They chose the same slope. They're going to use the point with the slope. They did the same formula. They got the same answer. We did good. So here's another perpendicular one. This would be a good time for you to pause and practice. So if it's perpendicular, it has to have a -1/3 slope. The only line that does that is B. Hopefully you worked your way through that, though, and found B to be the answer.